Hi everyone! So now you are on to lesson 3.6, which is the unit circle part 2. So the first part, after you've done lesson 3.5 and you've completed the problem set, is to start with what we've already learned. So I want you guys to pause the video, fill in degrees and radians from memory for each angle that we have on the unit circle, and you can see I've color coordinated it, similar to how we did on the last one. And then I also want you to fill in those terminal points on the unit circle for the first quadrant from memory. So pause the video now, and then when you unpause it, you can check your work and make sure we all have the same numbers. Okay, so now take a few minutes to look at your degrees and your radians and your first quadrant terminal points and make sure everything matches with what we have here. I also forgot to say this, but we also did the four corners at pi over 2, pi, 3 pi over 2, and 2 pi as well, since we know those points at the four corners since we're dealing with our unit circle here. So pause the video and check your answers if you need a little bit more time. Otherwise, let's go ahead and move on. What I want to do is pose a question to you guys. So if I am looking at the x and the y coordinates in quadrant 1, of my terminal points, I want to know how those are related to sine and cosine of those angle measures. So the question I have is here. What do you notice about the x coordinates and the y coordinates at pi over 3, pi over 4, and pi over 6 in terms of sine of theta and cosine of theta evaluated at those angles? So this is one of the big things we've been working towards discovering. So remember my 30, 60, 90 triangle. 30 degrees or pi over 6 radians, 60 degrees or pi over 3 radians. And remember my ratios. So if I were to evaluate sine of pi over 6, so I'm going to highlight my angle of reference here. Looking at this angle right here. Sine is going to be opposite over hypotenuse, which is a half. If I were to do cosine of pi over 6, well, that would be adjacent over hypotenuse. So what I want you to notice is this terminal point has those same two values. This is my x coordinate at that angle, my cosine, and this is my y coordinate at that angle. It's interesting. Now what I want to do is I want to do the same thing, except for now I want to look at pi over 3, 60 degrees, and I want to make that my angle of reference. Let's see if I can get this all on the same. There we go. I want to make sure I can see it all. So let's evaluate sine of pi over 3 radians, or 60 degrees, and cosine of pi over 3 radians. So when I'm looking at this pi over 3, now my sine is opposite, which is the square root of 3, over my hypotenuse, which is 2. And my cosine is adjacent, which is 1, over my hypotenuse, which is 2. But as I'm looking at this ordered pair up here at 60 degrees, I notice that my cosine is still the x value of that terminal point, and my sine is still the y value. So now I'm wondering, is that true for the 45-degree angle? So let's remember what that 45, 45, 90. So if I have pi over 4 radians, or 45 degrees, my ratios were 1, 1, and my hypotenuse was the square root of 2. So let's calculate sine of pi over 4 and cosine of pi over 4. Now this one here, because the opposite and the adjacent side are both 1, you just get 1 over the square root of 2 for both of these. And whenever I clean that up, I'm running out of space here and I really don't want to, but it just kind of is what it is. Let's go down here. 1 over the square root of 2, we know simplifies to be the square root of 2 over 2. So you can see how the sine and the cosine are the same thing here, so it's harder to see, but it follows my pattern where cosine of my angle theta corresponds to the x value on my terminal points, and sine of theta corresponds to the y value on my terminal points. And this relationship is going to hold all through this unit circle. And that's going to allow me to evaluate these trig functions at any angle on this unit circle and at those four corners now that I have this relationship. So now what I'd like to do is I want to go through each quadrant and do a little exploration so I can get those terminal points for all of these other angles that I've outlined on my unit circle through one rotation. So first I want to deal with the quadrant 2. So let's review those degrees in radians. I also want to do these corners. So here I have 90 degrees or pi over 2 radians. Next I have 120 degrees or 2 pi over 3 radians. 135 degrees or 3/4 of a pi or 3 pi over 4 radians. And then 150 degrees or 5 pi over 6 radians. And then down here I have 180 degrees or pi radians. So what we're going to use here is the symmetry of a circle. So if I know this point on the unit circle is the square root of 3 over 2, 1/2, using the same triangle here, I know this point comes from this triangle, the x value from the width of this, not the width, I'm sorry, the length of that segment from the origin to this point on the triangle, the height coming here. I know that if this triangle is reflected into the second quadrant, it has the same dimensions. So to get to this point right here, I'm still moving to the left root 3 over 2, which means my x coordinate is now negative. And then I'm still moving up 1/2 units. So the only thing that's changing here is that x value is becoming negative. If I were to do the same thing for my 45, 45, 90 triangle, and if this is foreign to you, then go back and watch that 3.5 lesson again. Reflect that triangle into the second quadrant, and we see that this point has to have the same values, except for now I'm moving to the left for that x value, making it negative. So this point here is going to be negative root 2 over 2, positive root 2 over 2. And then the final, which came from this triangle, when I reflect it into the second quadrant, this point now, this terminal point, is going to be negative 1/2 positive square root of 3 over 2. So now I know if sine of theta is going to correspond to y values on this unit circle, and cosine of theta is going to correspond to x values, I can now evaluate sine and cosine of this 2 pi over 3, 3 pi over 4, and 5 pi over 6 radians, and pi as well, because I know that terminal point at pi is negative 1, 0. So there's my quadrant 2, and I just want you to notice the relationship here that the points are the same, apart from the negative here in quadrant 2 at that x value. And just in general, going into the quadrants, you know that here in the first quadrant, you have positive and positive values, positive x, positive y. Maybe I should do that in this positive, positive. Here in quadrant 2, you have negative x values and positive y values. All right, so now let's move into quadrant 3. So here now in quadrant 3, we have quadrants 1 and 2 already outlined. So when I move to quadrant 3, let's review those degrees and radians. Remember, 180 degrees or pi radians. Next up is 210 degrees or 7 pi over 6 radians. Then I have 225 degrees or 5 pi over 4 radians. And then next I have 240 degrees or 4 pi over 3 radians. And then next would be that 270 degrees, 3 pi over 2 radians at this corner. So now, knowing what I know about the relationship of these points, I know here at 7 pi over 6, I'm going to have the same point as I have at pi over 6 and 5 pi over 6, but in quadrant 3, both x and y values are negative. So my point will now be negative root 3 over 2 negative a half. At 5 pi over 4, I'll have negative square root of 2 over 2, and then negative square root of 2 over 2, because x and y are both negative. And then at 4 pi over 3, I'll have negative 1/2 negative root 3 over 2 for that terminal point. So you can see how the relationship is developing with all of the points that have, wonder why that turned red, but you can see here that all of these angle measures that have a reference angle of pi over 6 have the same sine and cosine apart from a negative. All of these angle measures here and here that have a reference angle of pi over 4, they have the same values for sine and cosine apart from a negative. And then last, here, here, and here, where my reference angle is pi over 3, they have the same values apart from the negatives. Okay? And last one, we're going to go into the quadrant 4, and I will have a completed unit circle after this slide. And we'll talk about a few things after that. So here at this last corner, I've got 270 degrees, or 3 pi over 2. Then I have 300 degrees, or 5 pi over 3 radians. 315 degrees, or 7 pi over 4 radians. And 330 degrees, or 11 pi over 6 radians. And then this is 0 degrees, 0 radians, or 360 degrees and 2 pi radians. So now my points here in the fourth quadrant are positive x values, negative y values. So as I were to flip this triangle into this last quadrant, my point here at 300 degrees is going to be positive a half, negative root 3 over 2. At 315 degrees, or 7 pi over 4 radians, it'll be positive square root of 2 over 2, negative square root of 2 over 2. And then lastly, it'll be positive square root of 3 over 2, negative 1/2 when I'm at this 11 pi over 6. So I'm going to go through with yellow and outline again one more time since this is a cleaner picture. In quadrant 1, all coordinates are positive x values and positive y values. So I'm going to put A here for all trig functions are going to be positive here in this quadrant. In the second quadrant, we have negative x values and positive y values. So here you see the cosine is negative, but the sine is going to be positive. Now down here in quadrant 3, cosine is negative and sine is negative. And so here I'm going to write a big T, and that's going to stand for tangent is positive. And remember, that's because tangent of theta is equal to sine of theta over cosine of theta. And I believe that was reviewed back in section 3.1. And so if I were to take a negative over negative, I would get a positive. And then last here in quadrant 4, I have positive x values and negative y values. So I'm going to put a C here because the cosine, or the x value, is what is positive here in this fourth quadrant. So again, just in summary, sine of theta is my y value. Cosine of any angle theta is the x value. Tangent is sine over cosine, meaning that it's going to be equal to the y value divided by the x value. And now you can also find the reciprocals for the other trig functions. Cosecant of theta is 1 over sine of theta, meaning it's 1 over my y value at any angle here. Secant of theta is 1 over cosine of theta, so it's 1 over my x values. And cotangent of theta is going to be 1 over tangent, which is also cosine of theta over sine of theta. So that means it's going to be equal to the x value over the y value. So knowing this information right here about sine and cosine is what generates the other 6 trig functions. if I'm using this unit circle and these terminal points. Now, not only am I going to be able to evaluate all of the angles on this unit circle as I have outlined, I can also evaluate, without a calculator, all of their coterminal angles as well, since I know where the terminal sides lie. So here what I want to do, we've actually already kind of done this. Which trig functions are positive in each quadrant? So what I'd like you to do is outline in each quadrant, and let's make sure we're good with the quadrants. Quadrants 1, 2, 3, and 4. I want you to go through and outline all the trig functions out of the 6. Which ones are positive in each quadrant? And pause the video now, outline that, and then let's come back and check our work here in just a minute. Okay, welcome back. So hopefully you went through and you realized with knowing that sine of theta corresponds to the y value, and cosine of theta is going to correspond to the x value of those terminal points. We came up with these same conclusions. So in the first quadrant, all 6 trig functions are going to be positive. I'm going to put a big A here, all 6. In the second quadrant, sine is positive, and since sine is positive, sine's reciprocal cosecant is also positive. And sometimes you're going to hear me refer to sine and cosecant as friends, just because they go together, the reciprocals of one another. In the third quadrant, since sine and cosine are both negative, tangent and its friend cotangent, or reciprocal cotangent, will be positive because a negative over a negative is a positive. And then in the fourth quadrant, cosine is going to be positive, and so therefore its reciprocal secant is also going to be positive. You are likely going to hear this acronym often, that all students take calculus. Not a true statement, but it's an acronym that a lot of people use to remember who is positive in what quadrants. So if you remember all students take calculus, that can help you remember ASTC and remember who's positive in each quadrant. So now that we have all of this under our belt, especially this unit circle right here, it is time to get to our goal, which is really just to evaluate trig functions at these angles. So what we're going to do is I'm going to teach you 2 methods. The first is the unit circle method, and the unit circle method requires you to really memorize all of these terminal points and where they lie. And then the second method that I usually use is a triangle method. It still requires you to know what quadrant you lie in, but you don't have to memorize these terminal points. But if you know the pattern, memorizing this unit circle is not too bad. So let's do the unit circle method first. I feel like it's the most popular. And then we'll do the triangle method. So it says evaluate the 6 trigonometric functions at the angle 2 pi over 3. So your first step is to know where is 2 pi over 3, and it is here in the second quadrant. I've already graphed it here for you. And you got to know your terminal point. So my terminal point there is -1/2 root 3 over 2. I know in the second quadrant that sine and cosecant are the only 2 that should be positive. All the others should end up being negative when I'm done. So I have to know that the x-coordinate is the cosine and the y value is the sine. So sine of 2 pi over 3 will be square root of 3 over 2, and the cosine will be -1/2. Now I know tangent is sine over cosine, so when I do the square root of 3 over 2 divided by -1/2 for sine over cosine, I end up with negative square root of 3. So that'll be tangent of 2 pi over 3 is equal to negative square root of 3. And now when I'm doing cosecant, I'm taking the reciprocal of sine, so I have 2 over the square root of 3, and that simplifies to be 2 times the square root of 3 over 3 by rationalizing that denominator. For secant, when I take the reciprocal of cosine, I end up with -2 over 1, which is -2. And for cotangent, when I take the reciprocal of tangent, I will end up with 1 over negative square root of 3, and that simplifies to be negative square root of 3 over a 3. And you can also get that by taking -1/2 divided by the square root of 3 over 2. That leaves you with -1 over the square root of 3, which will lead you right back here. I decided to just take the reciprocal of the tangent. So now with that 1 point, knowing that 1 point, I'm able to evaluate all 6 trig functions at that angle 2 pi over 3. Usually I don't ask you for all 6, I just ask for the 1. And notice here that sine and cosecant are both positive and all of the others are negative. So now that we've gone through how to do that with the unit circle method, pause the video now if you still need all of this. I want to erase all of this and I want to show you how I like to do it using just my unit circle. So I'm going to erase now, pause the video if you need to. So I don't need that terminal point anymore, but I'm going to keep it there. So now when I'm using the unit circle, the reason that I actually prefer this the reason I like the triangle method is because when I got away from doing this often, whenever I was teaching some Algebra 1 and Algebra 2 classes where I didn't really need this as often, I realized that I really forgot that unit circle when I wasn't using it. But if I brought it down to its base, I knew if I know this original 30, 60, 90 triangle, which I have here, 30 degrees, 60 degrees, 90 degrees, if I know this, well then I can get these values because I know that if I'm evaluating sine or cosine any trig function of 2 pi over 3, I know numerically they have to have the same numerical value as the reference angle, which is pi over 3. So as long as you know your reference angle here, which is pi over 3, I can get all of the values that I need just by using my definitions of my trig functions. So here, if I'm looking at pi over 3, my opposite side is this square root of 3. My adjacent side is 1, and then my hypotenuse is 2. Well, sine is equal to the opposite over the hypotenuse, which is square root of 3 over 2. Cosine is equal to the adjacent over the hypotenuse, which is 1 over 2. Tangent is equal to the opposite over the adjacent, which is just a 1. Cosecant is going to be the reciprocal of sine, or hypotenuse, over my opposite, square root of 3. Secant is going to be the hypotenuse over the adjacent, and cotangent is going to be the adjacent over the opposite. So you can see how I can get all of the numerical values I need, and let's simplify those that I need. I don't need to simplify this one, the square root of 3 over 2, or half. Square root of 3 is just over 1 is just square root of 3. This 2 over the square root of 3 is 2 root 3 over 3. 2 over 1 is 2. And I need to rationalize this one as well. So I get root 3 over 3. And now the last thing I need to do is honor that this is lying in the second quadrant. And if you know that all students take calculus, you know here in quadrant 2 that sine and cosecant are positive and everything else is negative. So there are my final answers here. I know all of them. And you notice they're the same answer. I didn't have to memorize a unit circle. I didn't have to know that terminal point. All I had to know is the terminal side of where 2 pi over 3 is, the reference angle, and those original ratios that gave us the whole unit circle. So this is my preferred method. I really like triangles, and I sketch them all the time whenever I'm trying to think back oh, what is tangent of 5 pi over 6? I will sketch my triangle, get that value, and then just make it positive or negative based on where the terminal side lies. And this works great for any value that's on the interior. However, when you are on a four-corner, like in this next example, you are really stuck using that terminal point because there is no triangle that has one side of length 1 and a side of length 0. We're not going to be able to get a triangle. We're going to have to use this terminal point. So here I want to evaluate the 6 trig functions at the angle pi. So I go to pi, I get my point here, which is -1, 0. And remember, -1, the x value is the cosine, and 0 is going to be the sine. So sine of pi is going to be 0. Cosine of pi is -1. And now I'm going to get the other 6 based on those other 2. Tangent is sine over cosine, so I have 0 over -1. And 0 divided by any number is 0. Let's put that as like a definition. Now cosecant, I'm going to have to do the reciprocal of 0, which is 1 divided by 0. And that is not possible. That is an undefined number. So if you want to put a ruler over here, a number over 0 is undefined. For secant, I get 1 over negative 1, which is still just negative 1. And for cotangent, I get negative 1 over 0, and that is also undefined. So when I'm at one of these four corners at pi over 2, pi, 3 pi over 2, or 2 pi, I'm going to rely on those terminal points. Let's look at another example. All right, so here I'm looking at negative pi over 4. I want to evaluate the 6 trig functions at negative pi over 4. So first we'll do the unit circle method. So I've plotted negative pi over 4, which lands in the 4th quadrant, and I have that terminal point is the square root of 2 over 2, negative square root of 2 over 2. So therefore I know my cosine and my sine. So sine is the negative square root of 2 over 2. Cosine is positive square root of 2 over 2. So for tangent, I'm going to take sine over cosine. And since these have the same numerical value, I'm going to end up just getting a negative 1. Now for cosecant, you end up, if I take the reciprocal of this, I get negative 2 over the square root of 2. And now when I multiply by the square root of 2, I get negative 2 root 2 over a 2. 2's cancel, leaving me with a negative square root of 2. So it's a little messy. For secant, the same thing. I have to do 2 over the square root of 2. Rationalize the denominator, and you get 2 root 2 over 2. Cancel, leaving me with just a positive root 2. And for cotangent, if I take negative 1 over 1, I just get a negative 1. So here, using my terminal point, I've evaluated the 6 trig functions here at negative pi over 4. Notice, all students take calculus. Cosine and secant are the only two that should be positive, and that checks out with my work here. All right, so now I'm going to erase all of this, and I'm going to show you how I like to use just the triangle. Okay, so going back and using just the triangle, I would have to notice, all right, the reference angle is pi over 4. Easy enough. So I'm going to get all my numerical values by drawing my 45, 45, 90 triangle. And here it's kind of nice because my opposite side is 1, but my adjacent side is also 1. And then my hypotenuse is going to be the square root of 2. So sine is going to be opposite over hypotenuse, and that simplifies to be the square root of 2 over 2. Cosine will be adjacent over hypotenuse. It's the same thing. Tangent is going to just be opposite over adjacent whenever 1 is 1. Cosecant is going to be the hypotenuse over my opposite, giving me just the square root of 2. I'm going to need to erase this reference angle. Hope you had that written down so I can have more space. Secant is the square root of 2 over 1 as well, giving me square root of 2. And my cotangent is 1 over 1, giving me a 1. So the last thing for me to do is just know I'm in quadrant 4. And in quadrant 4, cosine and secant are positive, and everything else is negative. So applying those negatives as needed. And then I'm done. So in the last 3 examples, we have evaluated all 6 trig functions at a given angle. But realistically, what you're going to be looking at is something like example 4, where you're wanting to evaluate the trig functions here, different trig functions at different angles. And so here I encourage you to kind of experiment and decide, are you going to be a triangle person or a unit circle person? And neither is superior over the other. They're just 2 different methods, and it's really a preference. And you might find that in time you might switch. You might prefer something today that you might find cumbersome tomorrow. Who knows? So what we're going to do is we're going to do these first two together, and then I'm going to cut you loose to do the rest on your own, and then you can come back and check your answers. All right, so in the first example, I'm going to do sine of negative 7 pi over 4. So first step is usually just to see, where am I? Where is negative 7 pi over 4? I know positive 7 pi over 4 is here. This would be positive 7 pi over 4. So negative 7 pi over 4, same rotation, but I'm moving in a different direction now. So I land in quadrant 1. So since I'm in quadrant 1, I know everything is positive there, so I know I'm going to be positive no matter what I am. I'm evaluating the sign. If I'm a unit circle person, well, then I need to know what that point is, this terminal point here. And remember, negative 7 pi over 4 is the same thing as positive pi over 4. So my terminal point here is the square root of 2 over 2, square root of 2 over 2. And the sign is the y value. So I get positive root 2 over 2. Now, if you are a triangle person, you still had to know where you were. You're in quadrant 1, so you know you're positive. You establish that first. Then you're going to your reference angle, which is pi over 4. So you have this triangle. Sine is going to be opposite over hypotenuse, 1 over the square root of 2, which of course simplifies to be the square root of 2 over the square root of 2. So you get the same answer regardless of the method that you're using. All right, so I'm going to erase all of this work so we can do the next problem. I'll leave the answer there. So next we have cosine of 5 pi over 3. So the first question, no matter what method you're using, is where is 5 pi over 3? So 5 pi over 3 is going to be down in quadrant 4. And I know that all students take calculus. So I know cosine, which I'm evaluating, is positive here. So in quadrant 4, cosine is going to be positive, so my answer will be positive. I'll go ahead and establish that. Next, what I need to do is I need to know what that terminal point is if I'm a unit circle person. So that terminal point is 1/2 negative square root of 3 over 2. And cosine is the x value, so I should get 1/2, positive 1/2. If you're a triangle person, you didn't memorize that point right there, but you did memorize this 30, 60, 90 triangle. And the reference angle for 5 pi over 3 is just going to be pi over 3. And then the definition of cosine is my adjacent side, which is 1, over my hypotenuse, which is 2, giving me 1/2. So I get the same thing regardless of the method. So now what I think you should do is pause the video and give the last 4 a try, and then you can come back and check your answer when you're done. Okay, welcome back. First, let's go ahead and just check your answers and let's see how you did. So tangent of 7 pi over 6, you should have had the square root of 3 over 3. Cosecant of negative 3 pi over 2 is 1. Secant of 5 pi over 6 is negative 2 root 3 over 3. And cotangent of 12 pi is undefined. So let's quickly go through and see how we got these answers. So first, talking about the tangent of 7 pi over 6. First, what I did was establish that 7 pi over 6 is in quadrant 3, and tangent is positive there, so I knew my answer was positive. Then I referred to my triangle. The reference angle for 7 pi over 6 is pi over 6, and so then I knew I was just looking at the opposite side, which is 1, over the square root of 3, which is the adjacent, so opposite over adjacent, and then I had to simplify. Now for the next one, cosecant of negative 3 pi over 2, whenever I figured out where that was, I saw that I was up here at a 4 corner at 90 degrees, and I knew my point is 0, 1. Cosecant is going to be 1 over sine, and sine is the y value. So I get 1 over 1, which is just 1. Now for the next one, secant of 5 pi over 6, I established that 5 pi over 6 is in the second quadrant, and sine and cosecant are the only two trig functions that are positive in quadrant 2. So I knew my answer was going to be negative since I'm evaluating secant here. So I went ahead and I put the negative there. Then I went back to my triangle, and the definition of secant, I'm looking at the same reference angle here at pi over 6, but the definition of secant is hypotenuse over my adjacent, 2 over root 3. So then I had to simplify that by rationalizing the denominator, and I got negative 2 root 3 over 3. The last example, cotangent of 12 pi. Now 12 pi, since I know 1 rotation is equal to 2 pi, 12 pi was 6 rotations. So I actually drew this angle here for you, even though it was not easy to get all of them pretty small without looping around really large. So I landed here at one of the 4 corners, the original 4 corner, and my point there is 1, 0. Now cotangent's definition is cosine over sine, so the x value over the y value. So I got 1 over 0, which is undefined. So now at this point, you are all set and ready to do problem set 3.6. 3.6 basically looks like example 4 with more examples, so it gives you a lot of practice working with evaluating trig functions at all these angles on the unit circle. At this time in lesson 3.6, you're not going to go beyond 1 rotation on that unit circle, but you could have negative angles on the unit circle. So you're all set.